Hi, everyone. So many friends here. Really a pleasure to be able to introduce this tool that we've worked really hard on called eDNA Explorer. You've seen we had a booth yesterday. Thanks for coming by. Pick up some stickers. So eDNA Explorer is all about delivering fast, easy, and accurate information. So you can go to the homepage, and it's sort of like a LinkedIn with all of your project management and like informatics capacity in one place. You can explore what people are doing, who's where, what institutions are working on which projects. So maybe you work on fish and you realize your neighbor also works on fish. This is a place where you can go to see projects happening in real time. You can also get help running your own study, and you can analyze data just with the click of a button, upload your FASTQ file. It's very simple metadata. I'll walk you through that. So the mission is to make eDNA projects and eDNA collaboration easy, accurate, and fast, where you can create organism lists in just a couple days, also integrating geospatial data. You can make better decisions because you have a better idea of uncertainty. You can relate your eDNA data to more of the GBIF data that's available, and you have highly accurate methods that you're using to identify those taxa. So you may have seen us a couple of years ago, and we may have talked to you a couple of years ago when OceanKind challenged us to really figure out what's needed for eDNA adoption. We realized that there's these different webs, the web of life, people, and methods that all need to integrate together to be able to address like what is eDNA good for, how does it complement other methods, and how can we help conservation by working together and integrating the eDNA data with other data sets. So the team that's been building the eDNA Explorer includes other people that are not on this slide, but this is our team now. So our CEO, who you may have met, is Julie Stanford. She is a true designer. So she is thinking about how you are using the tool, and she is not an eDNA scientist primarily. Now she's become an eDNA scientist, but I think we are different from other tools in that we're really thinking about the user experience throughout with every click. My background, I'm the director of the California Environmental DNA Program, where I've been helping people get into the eDNA field for the last 8 years, and we've really recognized the power of data integration and methods integration. And then Jim Jeffers has his own really cool web software development firm, Sumo Creations, and we are now the leaders of eDNA Explorer, and we have a really great scientific advisory board, and we're growing our board of directors. So as we've launched this tool, which took 2 years plus to build, we've been talking to lots of people. Tons of people email us every week saying, hey, I want an eDNA study, and can I like monitor endangered species, invasive species? Can I track how, when I'm starting regenerative agriculture, how my farms are changing? Can I figure out how climate's changing? Is my restoration project working? So environmental stewards and environmental consumers are all coming to us with the same questions. The communities are actually very similar and are all really excited about sharing data and working together. And so this really is sort of testing the hypothesis that if we make large interoperable integrated data, that it will be something that everyone will want to use. So we can take eDNA, GBIF data, everything available from Google Earth Engine, Esri, NASA, plus all the knowledge and contributions by people that really need that local information, the local sequencing efforts for making your reference databases, go take your drinks, and take all of that energy and be able to put it together to actually enable everybody to make predictions about biodiversity across space and time, to be able to identify bioindicators and understand health, and to be able to discover environmental drivers and create models for identifying organisms, maybe based on their associates, not only having the information from that single organism, but using the whole holobiome that organisms bring with them to validate that something is present or has been there. So I'm going to give you a brief tour of the website. You can explore, click on a project like our LA River project, look at the contributors. So we're really focused on sticking to keeping attribution really broad and keeping that with the projects. So whether it's someone who collected a sample or you have a class of students, anyone can be a contributor. You can keep the project private or make it public. So here's a public project. You can see people's roles. You can check them out on the website. You can see the methods that people are using, and just learn about like what people are doing. Then you can see in the output, you have pictures and frequency charts of how many samples had a certain organism in them, and you can filter that based on how conservative or aggressive you want to assign taxa. You can filter that with numbers of mismatches, how abundant a taxon needs to be in your samples to be able to count. And you can also see trends across space, across your different sites, and across time. You can click on a species, and we can align this with GBIF information, so you can see how many samples that mosquito fish came up with in eDNA projects, and correlate that, or just look at the patterns with where it occurs in GBIF. And then you can do alpha and beta diversity analyses with many more variables than you may have thought were important or interesting. So you could look at your own site categories, but you could look at the different watersheds, or the temperature gradations, or the global human modification, or the amount of artificial light pollution, and relate that to your eDNA results. And often you're surprised by like, oh, I didn't realize that that was maybe important. I should start paying attention to these other Earth factors. So checking out other projects, I mentioned you can control if you want to publish the projects or not. We're going to be adding more to this and kind of adding to those onion layers for access. So who gets to see where the sample sites were? For all of the species, are there certain species that you want to not share with the public, but others that you do? Who gets to control the data, the messaging? So we're going to be adding more detail to the project management side. But if you want to add a project now, I encourage all of you, make a profile, add a project. You can fill out the templates. There's a simple meta barcoding template you download and re-upload. And coming soon, you'll be able to do more rigorous decontamination, not just based on your own data, but across global data. Like, we can look at how different DNA extraction kits, what contaminants they provide, like if we all are putting our data together. And we can flag species that are rare or common, expected, unexpected, or uncertain. We are planning to help you publish to GBIF directly here and to help you publish to NCBI. So we're sort of a temporary holding ground of about 3 years. And then where your data should be, you can trust that your data will be able to stay on the site. Hopefully we can extend that to be longer, but we would love for you ultimately to put your data in other long-term archives. And we're going to be using more and more machine learning to model if your site's looking typical. What is it experiencing? And how can you predict biodiversity change for the future? And we want to also highlight, rather than setting standards, but we have partners like iTrack-DNA that are creating really great standards. How can we highlight when those standards are met? Or like a certain federal agency, some reporting standard has been met. So ultimately, we'll be displaying health metrics and also predictive models that show you, hey, maybe methane gas is a predictor of this area's biodiversity being different from that area, and to make it really, really easy to understand. So we launched in November 2023. We spun out as a for-profit company because we want to be able to stick around. We want to be able to be VC-backed, seed-backed, and the insights are coming soon. So we hope you work with us. A little bit behind the scenes in my final minute, we have a really awesome reference database creator called T-Rex. It's powerful, and it's important when you're using phylogenetic approaches for a taxonomy assignment to have a really comprehensive reference database. So if you want a reference database made, we can make it for you. We use Pterodactyl. This is a tool we just submitted for publication yesterday for grabbing all the geospatial data and automatically assigning it to your samples. And for Trunco, Lenore Pipes, who developed Trunco, our taxonomy assignment tool, is working closely with us to continuously improve the tool. And it really does help when you have more that you can assign, you see more patterns. So all these elements are working together in one place. This is made for you. We think everyone will benefit if we share, especially if we share responsibly. And I hope that you come join us, run a study, analyze your data, compare your results that you already have to what's new, and that you start to use this as a platform to generate new collaborations and ideas. Thank you.